Would you like to make your own custom tools in Aseprite such as this one, but you have little to no programming experience and you don't know how to start or you feel it's too complicated? Don't worry, I got you covered. All you need is a text editor and, well, Aseprite of course, and the rest we will go through together step by step. And by the end of this video you will know how to make a tool to generate isometric boxes of any size and color and place them in your canvas wherever you want. If you're new to the channel, hi, my name is Norman and I've not only been making pixel art and animations for many years, I am also a software developer with many years of experience in Lua, which is the scripting language that Aseprite supports to write custom tools. So we will start really simple and with the very basics and expand our tool from there. And I will make sure that you can follow along with every single step, even if you don't know how to program or you've never written anything in Lua yet. To get things started, let's first have a look at the general workflow when writing a custom tool for Aseprite. If you go to File and then Scripts, you will see a list of all Lua scripts that are currently available. Each of those scripts is essentially a specific tool or feature that got added to Aseprite to expand its built-in functionality. So we want to add our own script to this list. If you click Open Scripts folder down here, a window to the location on your computer where those scripts are stored opens up. So here we just create a new Lua file. I am on Windows, so I right-click, say New and then Text Document, give it a name, in our case isometric box for example, and then we also change the file extensions from txt to Lua. If we now go back to Aseprite and we click File, Scripts, Rescan Scripts folder, we see that now our newly created script is added to the list. To run this new script, we can simply click it. But of course nothing happens yet, because we haven't added any code to that script file. So let's change that. As I said, all you need besides Aseprite is a text editor. There are several popular ones out there and I'm using Visual Studio Code. It's free and has lots of useful features and you can download it from the link that I have put in the video description. So let's open our new Lua script file in Visual Studio Code. Before we actually start typing something, you can go to the Extensions tab over here and type in Lua in the search bar to see a list of available Lua extensions for Visual Studio Code. I am using the first one by Sumneko. It's not strictly necessary to install one and you can skip this step if you want, but it makes writing Lua code more comfortable because it adds things like autocode completion and syntax highlighting. So let's start with writing some code to open a new custom dialog. To do this, we use the dialog class of Aseprite's scripting interface. Dialog with a capital D and parenthesis at the end will make for us a new instance of a dialog box. But if we run our script now, we still don't see any effect. This is because Aseprite does create a new dialog, but it doesn't show it yet and then simply deletes it again as soon as our script finishes. In order to show our dialog, we first need to store our dialog instance in a variable, so that we can do things with it at any later point in our script. We can pick a name for how we want to call our dialog, for example DLG. And we simply assign a new variable with that name to the result of the dialog construction, like this. DLG is dialog and then the constructor call. Now that we have our dialog stored in a variable, we can use it to call a function called show, like this. DLG : show, again with parentheses at the end because it's a function. And now when we run that script, we finally see something happen. It's not pretty yet and it doesn't do anything, but it's a start. Before we improve our dialog and add more features to it, now is a good moment to set up a keyboard shortcut for running our script. At least I find it a bit tedious to always having to go to File, Scripts and then click on our script in the list every time we want to try it out. It's just too many clicks. So let's close our dialog by pressing X, then go to Edit, Keyboard Shortcuts, and then under Menus, find our script in the list, click Add, and then press a key combination that you would like to use to run our script. It is good to pick one that is not already assigned to something else, and since our script will generate isometric boxes, I will use Ctrl+I. Confirm by pressing OK, and now we can run our script much more conveniently. By the way, you can also close the dialog that we are creating by pressing Escape on your keyboard. So using Ctrl+I and Escape is now a very quick way to test things out. Now let's go back to our script. In the first line, we now add the keyword local in front of our dialog variable. So what does that do and why is it important? Local makes our variable DLG available only within the script we are just creating. So basically it protects it from being modified by code that might be running in some other script. I will quickly show you the difference so that the effect becomes more clear. So if I remove the keyword local again and then I create another script that simply does say DLG show, and then we run first our script and then the other script, you will see that the other script indeed is able to open our dialog too. And if it can open it, it can also do all types of other things to it. And we don't want that. We want to have control over what happens with our dialog only in the place where we are creating and using it. In programming, this is called scoping, and it is good practice to always limit the scope of any object such as our dialog and only expose it to the parts of the code where it is really needed. So if we make our dialog local again, and let me quickly restart Aseprite for demonstrating this, because then we get rid of the previous global DLG that we created, and we now run both scripts again, one after the other, the second one will now complain that it doesn't understand what DLG means, and this is exactly what we wanted. So now we are good to continue. You see that currently our dialog box has the title script. So let's change that into something more meaningful. We can do this by filling in a title between the parentheses of our dialog constructor. For example, isometric box. Make sure that you add this between quotes, because otherwise the code will treat it just like another variable that it doesn't know. And now let's add some control elements to our dialog. Remember that this is what we want to achieve. So we want some sliders, a color picker, and 2 buttons. So let's start with the first slider. The point in our script where we should add our slider is between the first and second line. So let's make some space here. Our dialog, which we call DLG, has a built-in function called slider. And we can call it like this, DLG : slider and then curly brackets. We will explain those curly brackets in a bit and why it's useful to use those here rather than the regular parentheses. When you run the script, you see that indeed we now have a slider with an initial value of 100, and you can interact with it to set values between 100 and 0. Of course, this still doesn't do anything yet because we have not given it any further logic. To make the slider more useful, we can provide it with some input parameters. Those input parameters should be collected in a Lua table, which we can then pass to the slider function. A Lua table is written with curly brackets like this. And this is why we use those curly brackets here, because in fact we are telling the slider that it will now receive a list of things as input. You can see a Lua table with curly brackets like a container that holds some data. In our case, the first thing we can put in that container is a label for our slider. This label will be placed to the left of the slider and we can use it to tell the user what the slider value should represent. So in our case, our slider will represent the length of our isometric box. So we tell this to our dialog like this. Label is, and then in quotes, length. We can also tell the slider which initial value it should hold. Instead of 100, I would like to let it start with 0, so we can add it like this. Value equals 0. Since we will provide it with some more parameters, we can also format the input table like this. This doesn't change anything in code, it just makes it a bit more readable for us. Next, we give our slider an ID. This is another name just like the one we show in the label, only that this name is not shown to the user on screen and instead can be used internally within our code whenever we want to refer to this specific slider. Since the ID is not shown to the outside world, we don't need to make it look nice with capital letters or colon or anything, so we simply add the ID like this. ID equals length. We will see how an ID like this can be used in other parts of the code in a bit. And now comes the most interesting parameter, which is called onChange. This can be set to another function in our code. And what that means is that this new function will get called whenever the user changes the value of the slider. So just to demonstrate this, we can for example say onChange is say hi. And then we add another function in our script named say hi that simply prints the word hi. And we should not forget to make that new function local again, so that nobody outside of our script can call it. Also, we need to define where this function ends by using the end keyword like this. When we run this and we change the value of our slider, we indeed see that now a window pops up in which our script says hi. But of course, this was just a quick test. So instead of saying hi, we want to do something more useful when the user changes the slider value. What we want to do instead is update our isometric box. We still haven't really defined or drawn that box, but we can already prepare the code to update it by letting onChange connect to a function which we call update, and for now we will leave this function empty and go back to it when we know what to do with it. We can now create the sliders for width and height by simply copy-pasting what we just wrote for our first slider and just changing the label and ID accordingly. And as you can see when we run the script, we indeed now have our 3 sliders for drawing an isometric box. As you have probably noticed by now, the dialog is always a bit too small to properly show our title and sliders. And there are many ways to fix this. Most of them are a bit more complicated, so to keep things simple, we just fix this the easy way. Since we want to also create a color picker, we can do that now, because the color picker will be large enough so that Aseprite automatically fixes our dialog size too. Adding a color picker works almost in the same way as adding a slider. We can copy-paste one of the sliders and then rename the slider function to color. We can adjust the label and ID, and we can keep the onChange function as is, because we also want to update our isometric box when the user changes its color. The only parameter we need to change is value. Instead of value, we write color is, and then color with capital letter, and then again a Lua table with curly brackets. And in that Lua table we set R is 255, comma, G is 0, comma, B is 0. As you can see, we can create any color from script by providing RGB values in a Lua table. In this case, this means that we want to set 100% red as the default color of our color picker when the dialog opens, until the user changes it to something else. Let's quickly run the script to see if that works. Yep, it does. And as you can see now, also our dialog size looks much better. When we click the color, Aseprite's color picker widget opens and we can change the color to whatever we like. So now we have all control elements in our dialog. Let's actually use them to draw and update an isometric box. This means that we can go back to our empty update function and we will now start filling it with life. Remember that this function gets called every time we change any of the slider values, or when we change the color with the color picker. So what do we want to do in all those cases? First of all, we want to clear whatever we have drawn previously. So for now, we simply call a function clear, which we define above, but we do not yet fill it in. We just make sure again that this function is local and we end it with the keyword end like we did before. Now back in the update function, after we clear what we have previously drawn, we want to update the points that define our isometric box. So we just write update points and again define an empty function with that same name above. It doesn't really matter if the function goes before or after the clear function. The only thing that is important here is that it's above our update function. This is because Lua only looks above in our script for local functions like this. So if we put it below the update function, Lua wouldn't understand what we mean. So I will put it right above the update function and after the clear function. After updating all the points, we want to finally draw the isometric box based on the updated point data. So we make up another function and call it draw isometric box and add it above our update function again. Now let's fill in the details of these 3 new functions, and let's start with the clear function. To clear what we have already drawn previously, we can just remove the entire layer where we were drawing in. So this is a command of our application and we can do it like this: app.command.remove layer. Remove layer with capital letters. Since now we no longer have our layer to draw, we tell our app to immediately create a new and fresh one to use from now on. We can do this by typing app.activeSprite like this, colon, new layer, and then parentheses. Again, because it's a function. So let's try this out. If we run the script just like this, we actually get an error message. This is because in this case we do not have any ActiveSprite open. So then creating a new layer on our ActiveSprite will not work. So let's first create a new sprite manually by clicking File, New, and let's use some standard resolution of 320 by 180 pixels and RGBA mode and a black background. And now when we run our script, we no longer get that error. But we neither see a new layer being created, right? Well, this actually makes sense, because remember that we do that in our clear function. And that clear function is called from our update function. And the update function again is currently only called when we change a slider value, or the color. So let's see if that does have any effect now. Yes, once we click the slider and therefore change its value, we see a new layer pop up. When we try that again, we still see that one layer. But actually it's a new layer with the same default name, and the previous layer got deleted because our script ran the update and therefore the clear function once more. So this is good for now. We don't have anything in place to automatically delete that layer when we close the dialog again, so for now we just delete it manually. And with that, the clear function is done, and we can start implementing the update points function. In that one, we want to update all the points that we need to draw our isometric box. So far, we have no points at all. So let's first take a moment to think about how we want to set this up. Our goal is to have an isometric box like this, where the length, width and height of the box can be configured. Let's start with giving all the relevant points a name. A box like this can be seen as two floors, an upper and a lower floor, and in each floor we have points. So let's call this point upper left, this point upper right, this one upper top, and this one upper bottom. In the lower floor we can call this point lower left, and this one lower right, and this one lower bottom. So now let's create a Lua table in which we collect all those points. We can define that table at the top of the script as a local variable, for example right after we defined our dialog. And we can simply call it points. So local points equals an empty table. Note that we leave it here as an empty table and we fill it only with actual data in our update points function down here. Now let's also decide which point we want to use as the origin point of our entire isometric box, because this will make it much easier to move the box around via script later. So the first point we add to our points table we call origin, and for now we just place it at a fixed position in our canvas, for example at 100, 100. So we type points.origin is point with a capital letter and then 100, 100 as parameters to give to the point. All other points that we have just given a name we can now add to the points table in reference to our origin point. The upper left point we simply place in our origin, so we type points.upperLeft is points.origin. Now what about upper top? This one we can place in the origin and then move it a bit to the right and a bit up. This means that we can type points.upperTop is points.origin plus some other point, where the x and y coordinate of that other point determine how far to the right or up we want to move. But how far do we want to move in this case? Well, this depends on the width of the box, right? And the width of the box is actually a value that comes from one of our sliders. So let's say that the user has set the slider value to 32, for example. Then we would like to have this line be 32 units long. We can still decide what a unit means, and it makes our life easier if we count each of those two pixel pairs as one unit. So setting a width of 32 would mean that our isometric box should have a width of 32 of those double pixels. And this means that the point we need to add to our origin has a first coordinate of 2 times the width of the box, so 2 times the value of the slider value. And how do we get the slider value in script? This is easy because our dialog called DLG contains that information at all times in a table called data. So when we type dlg.data and then the identifier name of our slider, which was width, then we have our slider value. So this is why in the beginning we gave our slider an identifier, and we can now use it to read its data like this. What about the second coordinate of the point? This should also be the width value of the slider, but this time not taken times 2, because in y direction we move up by only 1 pixel each time we do 1 step in x direction. Moving up in y direction actually means taking the negative slider value here, because Aseprite counts the y coordinates of our canvas from the top row to the bottom row. So the top is 0 and the bottom is whatever the height of your canvas is. This means that now we have points.upperTop is points.origin plus point and then 2 times dialog data width and minus dialog data width. In the same way, we can now fill in all remaining points of our isometric box. But this should not become too much of a math or a 2D geometry tutorial, so I'll just quickly fill in those points for you and you can pause the video to type them in yourself. Feel free to have a closer look and check if you can follow the logic if you're interested in the details. So now we can finally draw the result of all this preparation work. To draw the isometric box, we just draw all the lines between the relevant points that we just defined. For that, we will write a new function called drawLine in a moment. Assuming that we have already written such a function, we can therefore simply call drawLine 9 times. Why 9 times? Well, because there are 9 lines that we want to draw. So we draw a line between upper left and upper bottom, between upper left and upper top, between upper top and upper right, and then upper right to upper bottom to finish the first floor of the box, so to speak. And then the lines between lower left and lower bottom, and between lower right and lower bottom, and finally the 3 remaining vertical lines that connect the 2 floors. And now we can write our function drawLine. We make it local as always, and we end it with the end keyword, and we expect 2 input points, right? So we call them start point and end point. But how do we now draw something? In our application table called app, there is a function called useTool. And we can call it in our case with 3 parameters, which we will put in a table like this. app.useTool, and then tool is line, color is DLG data color, and points is a table containing start point and end point. This is quite a powerful feature because it basically allows us to use the tools that you could also regularly use in Aseprite, such as the line tool in our case. So we specify here that the line tool is what we want, and as a color we take again the color from the data in our dialog, which is linked to the color picker value. Remember that we gave that color picker an ID that was simply called color. And as points we provide the given start and end points of our line. And that's already it. The drawing itself is that simple once we have all our preparation work done. So let's try it out. As you can see, we can now use the sliders to determine the size of the box in all 3 dimensions. And we can update the color dynamically using the color picker. In my version, I had a few more things, such as 2 buttons for accepting the changes or clearing the current drawing, and 2 more sliders with X and Y values for repositioning the isometric box within the canvas. Remember that we added an origin point to our script, so X and Y modified that origin point. Also added a function that fills the faces of the box in the same color as the lines, but slightly desaturated and darker. To make the dialog look a bit nicer, I also added 2 separators with a title that group the elements in our dialog box. I think you already have quite some new information to process if you have made it that far in this tutorial, and well done you if you did. So I will not go into the details of those additional features now, but instead point you towards 2 useful links in the video description. One for the Aseprite API documentation and one for a free online version of the first edition of the Programming in Lua book. There you will find tons of follow-up information, so you can write something completely new from scratch or expand the tool for creating isometric boxes with new and cool features. If this is what you want, you might actually want to check out the fundamentals of isometric pixel art, which I have explained in this video.